My mic is muted. All right. Well, um, so there was a great introduction that anybody listening remotely missed, and basically all the points are here in the welcome to the workshop. All right. So if you are watching remotely, please feel free to use the Etherpad. I guess I should go over that. So there's sort of two links to keep in mind. One is there's an Etherpad where people can ask questions or post code or otherwise interact with us either in the room or remotely. If I write code that is long or even not that long, I'll post it here, and you can copy and paste the code from here into your Python, and that's at the link in the Etherpad. And then there's a link to in the source code repository where right now it's empty except for some data, but this is where I'll put the source code that we're working with today at the end of the workshop. So there'll be a long-term record of it. All right. So let's see. So I'm going to work in a Binder environment. So I'm going to pull this up. If you don't have a working Python install and you're watching remotely, you can use this. I'm just going to open it in a new window, and it'll just take a minute. And what this is going to do is link me to a Jupyter Notebook running on a remote computer. And on that, then I can get a shell window and some editor windows on that remote computer. And it sort of means I don't have to install anything. So to get to the console here, I go to File, Open. This gives me a Jupyter Notebook console. And here I can both create files. So I'll do new text file. And I can change this to I don't know, countends.py, which is the first file we're going to be working with. And I can go back to the console, and I can also create a terminal window here that lets me, where I can interact with the Python code that I'm writing in countends.py. So you don't have to worry too much about exactly what I'm doing here unless you want to use it too. But basically, I have a terminal window, I have a text editor, and that's all we're going to need today for writing Python. Yeah, go ahead.
How did you get the terminal window again?
So I went to in the console. You hit the console? I go to New, and I do Terminal. Sure. Sorry. Okay. And if anybody in the room has questions or problems, just when Jessica comes back, just flag her down or flag me down if you need help. Okay. Okay. So let's see. Where are we going to start? So we're going to be doing something very exciting today. We're going to be counting the number of ends in genomic sequence. It's a super boring problem, and the point is that actually it doesn't really matter what problem we choose as long as we can get some data and some code running, and then we can work around the code. So we do need some data though, and we're going to actually be using this FASTQ file of data here, and you can download it directly either by clicking on the link and downloading it to your laptop, or there's a curl link here if you want to use that. So I am going to let's see, what am I going to do? I am going to download it to this directory. Why is this not working? Let's see. Okay, well, so that's not great. There we are. Okay. It's telling me I can't download it, which is a little bit of a problem. I have to figure out how to fix this problem before. Can I do wget? Things you don't test in advance that mess you up. Okay, and I'm just going to remove a few things from my environment here because they're going to be distracting. The data is linked on this under the data and problem. So you can, you should have gotten the link to this whole page in an email, and then it's under data and problem. You can click on this FASTQ file of data, or you can run that curl command if you're at a prompt. And it's about an 8 megabyte download, so it shouldn't be terribly challenging to download.
Perl didn't work in mine either.
Yeah, so you can do wget on that URL, and it'll also work. Okay, so so if we look at the data, so I'm going to just do. I'm going to look at the data with. I wonder if less will work. Oh, okay. I'm going to look at the data by de-unzipping a little bit of it and piping it through head. You don't need to. Sorry. Yeah. Anyway, I know this will work. So I'm going to look at this data. Just to look at this data, it's a FASTQ file, and we're not going to be doing anything particularly interesting with parsing or anything. This is just a file of sequences that comes off of a sequencer. This is from an E. coli data set that was produced in that was published in 2013. And the problem that I want to set up for today is that we want to get overall statistics on the number of N characters in sequences in this file. Now, if you haven't worked with FASTQ files before, they're essentially a series of text records. Each text record is 4 lines. The first line is the name of the sequence. The second line, which is here wrapped on my computer because it's longer than the width of my terminal. The second line is DNA sequence. The third line is a plus. And the fourth line is the quality score. And we're going to completely ignore the quality score for now. We're just going to be and we're actually going to ignore everything but the DNA sequence for now. Okay? And the problem that I want us to tackle is the problem that I'm going to implement a little solution for is I just want to get an overall statistic on the total number of N's, the fraction of this file, of the sequences in this file that are N basis, where N means basically error or uncalled or whatever the sequencer is. So I guess I don't know how many people in this room or watching remotely are genomics people or bioinformatics people. Basically, the possible values, the possible correct values for that sequence line, which is the second line of each record, are A, C, G, T, and N. And N generally means we didn't know which of A, C, G, or T to put here. And it can be useful to know how much of your sequencing data set is uncalled, in the sense of we didn't know what to put there. Really, you could substitute any other thing you wanted to do. I can show you, if we have time at the end, I can show you, we can swap the scripts around so that we're measuring the number of A's and T's and G's and C's, which is actually sometimes a useful thing. But again, the problem doesn't really matter. We just want an excuse to write some code. So in terms of writing some code, I'm going to switch to my editor window. Let me just make sure the language here is Python. Okay. And let me write some really straightforward code for working through this file. Okay. So the file name is E. coli ref 100K. Let me unzip it, just so that I don't have to worry about parsing a gzip format. And if you look at it, it's 22 megabytes, and it's got 400,000 lines in the file. I don't know if people can people sort of see that text, or should I make it bigger? I can make it bigger. I make it bigger. Now it's too big. Anyway. So let me do that ls minus L again. I'll do the WC. And it's 400,000 lines, which actually works out to be 100,000 FASTQ records, and it's 22 megabytes in size, roughly 22.7 megabytes in size. Roughly. So let's just load in some sequences and start doing some counting. Okay, so you can follow along with me if you want, and just remind me to copy and paste the code when I'm done writing it. And I'll put it in Etherpad, and that way you can, if you're not as fast a typist as me, then or you want to watch while I'm typing, that way you can run the code yourself. So just to get started, if I were just writing straight up Python code, to do this, I would say, well, I need to open the file. So I'm not actually a particularly good Python coder. So there's all sorts of tricks and context managers and stuff that I'm not going to use here. I'm going to do the thing that I would have done in grad school when I was starting to code. Just write some code out. Okay, so I'm going to hard code the file name in. So what was it called? It was E. coli ref dash 100k.fq. And then for line in FP, pass. Okay. So what this is going to do is it's going to open the file. It's going to iterate through the file one line at a time. Okay. And then there's a variety of ways to get what I'm really interested in is the second line of each record. So I'm interested in row using zero-based indexing. I'm interested in row 1, row 5, row 9, row whatever. So and I'm not going to write a whole FASTQ parser here. There are FASTQ parsers that you should use if you're going to do this, but I don't want to make people install stuff. So I'm just going to do the worst, most horrible thing you can do, which is write my own little FASTQ parser in front of you. And it's not even going to be a good one, right? It's just going to be like the sequence line of each record. So let's do n equals 0. We're going to keep track of each line in here. And then we're going to say if line modulus 4 is equal to 1, that is, if it's the second line in each record, now that is a line that I want to pay attention to. Okay. Now at this point, I could make a mistake, and I could try and do something more clever. But what I actually really just want to do is save this and see if it breaks. Because if this doesn't run, then I have problems, right? So I'm actually a really conservative, coder because I've been doing this for a long time. So there's the code in the Etherpad, and I'm going to go run this code in this window, and I've called it count ends, and you can see it run there. Okay. Okay. It didn't break. I don't have any syntax errors in my code. It probably opened the file. but we do have a problem, which is that the output's empty, right? So I don't actually know if it did anything. So let me go back in and make sure that it did at least something sensible. And I'm going to say I'm just going to put a print statement in. If I save this, and I go back here, and I run, okay. So I put in a print statement that told me to printed out the number of lines I'd seen, and it gave me 400,000. That matches what we got with word count, so we're good. Okay. So now we want to do something with this window, with this sequence. So we're going to say, let's just say seek equals line. Okay, one important thing about line that you need to know. Actually, I'll show you a trick. Should I show you this trick? Yeah. Okay, let's take a look at what this line actually is. And the trick I'm going to use is, sorry, the tabbing here is really annoying. There we are. I'm going to do this, and then I'm going to break. Okay. So here what I'm doing is a trick where I'm converting sequence into a tuple in Python, and you'll see why I'm doing this in a second. And the goal is to see if there are any hidden characters in seek. So let me just copy this here. And if I go back and I run this, it should break. Whoops, I forgot to save it. Let me save it. If I go back and I run this, okay. I now get this. So first of all, I put the break in, so I'm exiting immediately without really reading 400,000 lines because I didn't want to print out that much. And what I got was the what's called the internal representation of the sequence string. And what you can see here is that there's that \n at the end of the sequence, and that's the new line that in any text file there are the invisible whitespace characters at the end of each line that tell you that this is a new line, right? And the reason I did that is that if you just put a print statement in, then it'll print the new line, right? If I just did this, when I run this, what you'll see is that you can infer that there's a new line at the end because there's a blank line between the sequence and the one. But you don't actually know if there's like a bunch of spaces in a new line or if it's just a new line or what. So this internal representation, which I turned it into with the tuple, let me see these hidden characters. Okay. So, yes, go ahead.
What was it about that? Is it the, like, I don't know. I understand what you're doing, but I understand the code and how it's working.
So does this help? So the question is, what was I actually, what was the syntax of what I was doing? So I'm creating a tuple, which is a read-only list first, and then I'm printing that read-only list. And it's just this little Python trick that if you print out a list, Python will give you the internal representation of the things in the list or the tuple rather than running print on every element of the list. It's just something about Python. Yeah, there's no right. So today is going to be a mixture of like stupid what's stupid pet tricks with Python, plus some more conceptual stuff. But here so. And I'll try and indicate when it's just like something stupid that I picked up that I found useful, like this, versus, hey, you should do this, whatever you're coding in. Okay? Okay. So if I run this, you'll see, okay, so what do I do about this? Well, the first thing is I don't actually want the white space in the sequence, so I'm going to run this very useful function called strip. And what strip does is it trims leading and trailing white space from sequences, from strings. And if I run this, you'll see what you expect, which is that now that I'm doing this, we no longer have the new lines and stuff, so we're good. Okay. Now, if what I want to do is get statistics, if what I want to do is I want to get statistics on the number of ends in my file, I have to know two things. I have to know the number of ends, and I have to know the total number of sequences in the file, right? I have to know the total number of bases in the file. So I have to keep track of that with two counters. So let's do this. We're going to do total bases is 0, and we're going to do total ends is equal to 0. And here we'll say total bases plus equals len seq, and total ends plus equal seq.count n. At this point, I'm going to get rid of all of these extra statements. And so I just have sort of, okay, I'm loading in the second line of each record, and I'm counting the total length, and I'm counting the total ends. Let me just put this here and copy it. Okay, so at this point, I'm doing something bad, which is I have a variable named n, which is going to be very confusing in a script where we're counting the number of ends. So let me just do count and count and count here. You don't need to do that if you're not going to be confused, but just for the record. Okay, so last but not least, I kind of probably want to print out the new things that I'm recording. So print total ends, print bases, so on and so forth. Now if I run this, so I put in Etherpad, and if I run this now, I screwed up. I need to make it if count %4. If I run this, you'll see, okay, I have 400,000 lines. I have 10 million bases, and I have 20,000 ends in this file. So great. Okay. So now I can print out the number that I wanted to know, right? I can print out which is the fraction of bases. that are ends, and this would just be print total ends divided by total bases. And I'll get rid of all of this. And it's probably a good idea to put in like some text here, like fraction of bases that are ends. I think that should work. I'll do like total sequences count. All right. And if I run that, okay, that's not exactly what I wanted to print out, but it'll do, right? Okay, so we do have one problem, which is that I'm doing integer division. So which Python version am I running? Oh, 2.7.10. So I should be running Python 3, and that'll print out something better. So what you're seeing here is actually one of the differences between Python 2 and Python 3. Python 3, the division, when you take two integers and you divide, you'll get a floating point. With Python 2, you'll get an integer out, so it'll automatically round. It'll automatically chop off the floating point. So we want to be running this stuff in Python 3. Okay, so total sequences 400,000, and 0.2% of the bases are ends. We also print out all sorts of other stats. Okay, so are we all good so far with this Python code? Yeah, everybody seems to be following along. Okay, so does anybody have any opinions about this code? Anybody see any problems with it? So don't think about, I mean, the code, I think, okay, I'm going to make a very dangerous statement right now. The code obviously works, right? So you can have opinions about the code, but so I'm not really asking, like, does the code work? I'm asking, what are the potential problems moving forward with this? Anybody see any? I can identify at least two that I'm thinking of, but of course I thought about this in advance. The file name is hard-coded. Very good. Yeah, right. So now if you do this the way a lot of people do when they're just whacking around with data analysis code, they would make like another version of this file for when they had like another file that they wanted to count the number of ends in, and then they'd end up with like 3 different versions of the Python script, and then they'd fix a bug in one and they wouldn't fix it in the other two, and that would be a problem. Okay, any other problems? What happens if I don't pass this a FASTQ file? What happens if I get the wrong kind of file? Bad things, right? Who knows what it's going to do? So right now there's no error checking on the input. It's another problem. What happens if I pass it an empty file? Any guesses? Right. So if you pass it an empty file, okay, well, I don't have a way to run this on an empty file yet, but suppose I ran this on an empty file. When I ran this on an empty file, it would crash with a division by 0, right? Because if I, yeah, so you see the issues, right? There's a couple issues. So let's take care of the first one, because I already had to edit the file and put a new file name in. So, and you've probably all seen this before, but the way you can get a file in from the command on the command line is by using the sys.argv, the sys module with the argv list. And so what argv does is it just takes everything on the command line and puts it in sys.argv. What Python does is it takes everything on the command line and puts it in sys.argv. So argv square bracket 0 is the actual script that's being run. Argv square bracket 1 is the first argument to that script. Argv square bracket 2 is the second argument, so on and so forth. And so now, if I run this, just put it at the bottom of the Etherpad. Now if I run this, and I just run it, it's going to say list index out of range because there's no arguments being passed in, so I can pass it in like E. coli ref 100k.fq, and it will load in E. coli ref 100k.fq and give you a thing, right? So that's pretty handy. And actually, I really like putting in loading sequences from. I really like putting in this kind of statement just because that way I know, later on when I add additional arguments, I actually know where the thing's coming from. I actually know what it's trying to load. And if I run that, you'll see loading sequences from E. coli ref 100k.fq, et cetera, et cetera, et cetera. Okay. Okay. So let's say that we have this this code now, and let's break it into some functions. Right? Let's have one function be a function that loads in the sequence, and another function be one that actually counts the number of ends in the sequence. Right? So that's maybe a natural division of labor. I can tell you it's probably a natural division of labor because I've written lots and lots of this kind of code before. You have to figure out where the natural division of labor is in your code when you're writing it. But in general, if you have file parsing code and then data analysis code, you want to keep them separate so that you can load many different types of data in and analyze it all the same way, or load many different files in using the same file parsing code and then analyze that data different ways. So so I'm going to introduce. Okay, well, I'll show you what the code does, and then we can work out why it's confusing. So let's do one function will be load. Let's do load sequences, and we'll have a file name. It'll be a function that takes a file name, and this will be just our code to walk through the to do this. I'm actually going to copy and paste it. And I think there's probably a way to do something clever to tab it all over, but I'm just going to tab one in a line at a time. And we also need to do fp is equal to open file name. Okay. So this is just the same code that we just had. We just copied and pasted it and put an open in. The problem with this code is that it also has the counting in there. So I'm going to get rid of the counting. And I'm going to say what we want to do is return sequence. Okay. There's a couple different ways of doing this. Maybe I'll do it the way that's a little easier to understand. Okay, so what this function does is it initializes an empty list of sequences. It opens the file name for every line in that file. It takes the second line of each record, strips off leading and trailing white space, and appends that sequence to the list. And then at the very, very end of that for loop, it returns the list. That in. Okay. So if we wanted to use this, we could now go back down here and we could say seeks is equal to load sequences from sys.argd square bracket 1. And now this for loop can be a little bit nicer. We can say for seek in seeks, total bases plus equals len seek, total ends plus equals seek dot count n, and count plus equals 1. Right? So this is hey, look at that. So we'll save it, and I'll just copy it and put it in the Etherpad. Okay. Okay. So there is one problem with this code that we may get to later towards the end, which is that if you have a really big list of sequences, if you have a really big file of sequences, suppose you have a 10 gigabyte file of sequences, you're loading an awful lot of data into memory here, and that list of seqs is going to get really, really, really big, and you're going to need a big computer to run this on. And there's ways of dealing with that using something called generators, but I don't want to do that later. What? Yeah. Yep. Okay. So the other thing that we want to do is we want to put this count functionality in. And I'm not actually going to put the for loop in. I'm just going to have the count functionality that extracts the number of ends and the number of bases from each sequence. So I'm going to do count ends, and it'll take a sequence, and it'll say n bases is equal to n seq, and n ends is equal to seq.count n, and then return n bases and ends. And then down here, I can now change, let's see. Now it gets a little bit tricky because I sort of did this in a silly way, but I can do n bases, comma, n ends is equal to count n seq. And here I can say n bases and n ends. So this is not really a great simplification because I created a function that the count ends function is kind of short, and it does exactly the same things as our other code did, and it creates these variables that you then return and have to assign and add and so on. So it doesn't really simplify the code. What it does do is let us generalize the code down the road, and you'll see that a little bit. Just as one example, think about the situation where the sequence has to be cleaned up a little bit, where the sequence may be lowercase, for example, or where you want to count things that are other than ends, and you want a function that's like count non-ACGT. That code becomes more complicated, and so now we can just encapsulate all that code in the function and change that one function, and all of the code that depends on that function will get the new behavior. You don't worry if we'll talk about that when we get to it. Okay, let me see if this runs before I pass it on to Etherpad. Doesn't run, and that's because somewhere I have an if statement here. In load sequences, I'm not actually keeping track of the count. So I'm going to show you another nice trick, which is rather than incrementing count every time you're in the for loop, we can do this, where we put an enumerate wrapper around the thing we're iterating over. So here, FP is an iterator. And what we're going to do is we're going to ask the iterator, we're going to count along with the iterator. And so what enumerate does is it takes whatever is normally going to be returned and it adds a count onto it. So if you think about what we were doing before, we were setting count equal to 0, and then we were incrementing count each time through the for loop. This enumerate wrapper does that all automatically for us, so that we don't have to keep track of things in the same way. Does that make sense to people? And enumerate is actually an example of a generator that we'll get to later on. Did you have a question? No? Okay. So let's see if this works. And it looks like it works. And I'll just copy all of this over to here. Okay. Great. So we now have this, and we're going to go into sort of function overload here. And we're actually going to wrap this main stuff that actually does something in another function. Yeah, please.
Can you remind me what happens if you return two variables? So like count ends that has n bases and n ends, is that like a list or a tuple?
It's a tuple. Yeah. So what's happening here? So thank you. Yeah. So what's happening here is that this is equivalent to, this is sort of the shorthand for this. Python will automatically package and unpackage tuples if you put a comma in the middle. And so essentially you're returning two things at once and two things from once. And I have to say, like, before coming to Python, I was a C programmer, and returning multiple things in like some other programming languages is a gigantic pain in the butt, right? So it's really nice that I just want all these variables out of this function. Okay. Any other questions? If remote people have questions, please dump them in the Etherpad, and I'll see them when I copy and paste code in. Just put them at the bottom of the Etherpad. All right, so we're going to do one more round of encapsulating code in functions. Should we? Well, let's do it while we're converting things to functions. So in my scripts, I tend to have a convention that the main function in a script is called main. So I'm going to define a new function, and the function's not going to take any arguments, and it's not going to be something that I reuse. I'm just going to put all of this code in. And then I'm going to call it at the bottom. So I just tabbed everything over and encapsulated in a function called main. And there is a point to doing this. I do this for all of my scripts, but it's a little premature at the moment. So if I save this and I run Python 3 and it works, so I will put this at the bottom of the Etherpad. You can see where we are with this. Okay. So, right. Any questions at this point? Let me just come back to here to make sure that which things I've. Okay. So now we're ready to. Now let's say we're done with this script for the moment. Okay. Suppose we go off and we happily use this, and life is good, and we get our numbers, and then we go to our advisor, and our advisor says, okay, well, I see that like only 2%, 0.2% of the sequences of the bases in our sequencing run were ends. But what I kind of want to know is, are there sequences that have a lot of ends? Is it that we have like, on average, we have ends sort of uniformly for our sequencing file, or is it that there's a subset of reads of sequences that have a lot of ends in them, and then there's a bunch that have basically like no ends in them, right? And the problem with that is that this code doesn't really get at that, right? This code is an average over the entire file. But if you look at how we broke out the code, we can actually reuse both of these functions to get a per sequence list distribution of ends, right? We have to load the sequences in. We have to count the ends in each sequence now. But rather than averaging over all the bases we load in, now we can actually just use these functions to instead look at each individual sequence. But we don't want to modify this script to do that. We want to write a new script. Because this script's still useful. Right? Never take working code that does something that gives you a useful number and then like change it and add new functionality that eliminates the old functionality. Just keep it around and make a new script. So what I'm going to do is I'm actually going to, I'll close this for, well, I don't want to close it. I don't want to get, I'll try and remember when I switch, to point out when I switch files. But let me start a new file, and I'm going to call this file, I don't know, ndist.py. Python. And this file is going to, I'll rough out the code. This code's not going to work just yet, but let's see, I want to import sys, and I want to do seeks is equal to, what did we call it? We called it load sequences, sys.argv sub 1, and we're going to call, and then we can get a distribution. We can say for seek in seeks, we get n bases and ends from count ends seek. I think those are the function names we used. Now we actually want to keep track of something other than the total. Now we want to keep track of the distribution and of ends, and let's just set this up. Let's just say bins is an empty list. We can say bins.append. It's actually bins is probably a little wrong term to use, but what should I call it? Tracking. I don't know. I'm sure I'll come up with a better name for it later. Tracking.append and ends. And what this is going to do is it's going to keep track of the number of ends on a per sequence basis. So at the end of all this, we're going to get a list called tracking that is the same size as, the same length as seeks, but instead of having A's, T's, C's, and G's and ends in it, it's going to have the number of ends in each sequence. And if you want to see what that's like, we can actually just print it. And now we run into the problem that we don't actually, this isn't actually code we can run because we have these two functions that we define, and they're not available here, right? If we save this and we run it, it's going to say load sequences is not defined because we haven't defined that function in this script. Now there's three solutions to this. One of them is clearly wrong. One of them will get you in a lot of trouble, and one of them is the right way to do things. The clearly wrong thing is to say, well, I know I have working code somewhere else, but I'm going to write a whole new function called load sequences because I'm in the mood to type a lot today. But that's clearly a bad idea to just like rewrite a function that you already have somewhere else. The sometimes okay but generally a bad idea approach would be to copy and paste the code. So let's just start by doing that. So we'll go over to count ends, and I'm going to copy load sequences. Whoops. I'm going to copy load sequences and count ends. I'm going to move them over to this function, to this file. And here the trick is I have to put them at the top because they have to be defined before I use them, right? In Python, you have to define the functions before you can use them. So literally, I just copied and pasted them to count ends into NDist. Sorry, and then I'll save this, and let's see if this works. Count ends not defined. That's because I called it count capital ends. Okay. We'll save this and we'll run it. Okay, and now I'm printing out tracking. And so you can see tracking is a list that has 100,000 entries. I'm not going to count them all, but there are probably 100,000 entries in tracking. And most sequences have 0. A few sequences have 1 end in them. You can see the ones sort of like up here, for example. It's the 1. Okay. Now, the only problem with this code is that down the road, we're gonna find and fix some problems in load sequences and count ends, and we don't want to have to fix those problems in multiple copies of this. So this is where code reuse comes in. Probably the right way to do it, especially in a situation where you have one project, you have several sets of files in one directory, is to actually create a module. And a module is sort of the basic element of code reuse in Python, and it's the first time I remember thinking back, this was almost 20 years ago. Okay. I remember realizing that just how easy it was to make modules and how much this would change my life in terms of making my code reusable by me, because I'd had a lot of experience in other programming languages, and I'd never found it this easy to reuse code. So what I'm going to do is I'm actually going to put these two functions, the functions I want to reuse, in a third file, and let's just call it, this is dangerous, let's just call it utils. Calling it, I have like 1,000 utils.py files in my computers that all have different functions defined in them. It's like a really bad practice, but to like name something totally generic. But I do it anyway because I'm not always creative at coming up with names. So I'm going to copy these functions out of this file, and I'm going to create a new file, and let's call that new file utils.py. And in utils.py, I'm going to put these two functions, and that's it. There's nothing else in utils.py other than these two functions. So let me just save this, and I'll copy this into the Etherpad. Utils.py consists of these two functions. And then in ndist.py, I can now say import utils. And I can now call utils.loadSequences and utils.countEnds. And all this says is take the Python code in the module utils.py, load it, and then because I loaded it into the namespace utils, which is the name of the module, I can just call those functions directly. So I'm going to, before I copy this into Etherpad, let me run it. At least it doesn't break, and it returns what looks like the same output as before, right? So I'm going to call this a win. I'm going to say this is ndis.py. Now, this file has a couple of advantages. One advantage is it's pretty easy to read, I would argue. Right? I mean, we didn't really comment what we're doing, but I don't actually like putting that many comments in my code, because I think that at least with Python code, I can usually make what the code is doing fairly obvious by naming my functions and my variables properly. So here, utils.loadSequences, what it's saying is pretty obvious, I would say. And then utils.countEnds is, again, another nicely named function that tells us what the functions do. OK, who's confused? Who has questions? Anybody?
Does that work without using the utils bits?
So, OK, so what happens if you just call load sequences? Is that what you're asking? Name load sequences is not defined. Yeah. So there's something you can do. You could say from utils import load sequences. And what that says is go into the utils module, take the function load sequences, and bring it into the script namespace. And that'll work just fine. The problem with that is that as soon as your scripts become complicated, you start to wonder where the heck names came from. And it's fine if you actually, if I want to know where load sequences came from, I can find it. It's at the top of my file in the from, whatever import. I tend to find there to be more value in sort of being really explicit about where I'm getting things from. If I had like 50, if I had only 2 functions that I'm using, then I might sometimes do from x import y. If I have 50 functions, you really don't want to do from whatever import whatever. There's other tricks you can do. I'm not going to show you the code to do this, but you can do from utils import star, and it will take all the names in utils and bring them into your local namespace. But don't do that, because if you have 2 modules that have the same names in them, then whichever one is imported last will overwrite the names that were imported previously. So there's no check on that. So generally, I would say this is a good saying what library I'm using, what module I'm using is good practice. Okay. You can do something tricky. You can say import utils as foo, and that will also work. I think. I should do this with Python 3, but yeah, that will also work. And here what we're saying is import and then rename. And this comes in handy when you have really long, complicated module names, like when you're using some of the libraries that have modules within submodules with submodules. It's like, you don't want to be writing an example from yesterday. sklearn.metrics.this.that.function starts to become kind of long in your source code. So you can like say from sklearn.metrics.whatever import import x as y and name it something appropriate. Okay, so this is probably on my. I mean, it's hard for me to oversell. I feel like I'm overselling this, or maybe I'm not sure under or overselling it, but like modules are the bomb. Right? This is how you actually write code that you can trust, that you can reuse and trust. So, and I'm not going to show you today, but if you write a useful module, you can actually, it's like super easy to distribute it to other people too. It's like, and where other people can include yourself in other projects. So there's a couple ways of making this module available, utils.py available. You can just copy it from project to project to project, which is something that I sometimes do. Or you can actually post it to the Python package index and then import it from there. And that makes your code available for everybody to use. And there's pluses and minuses to that, but it can be a lot more work to maintain that. But this is sort of the basics. Okay. So we still haven't answered our question, so let's do that. I don't really want to plot anything. So do I want to write a poor man's histogram generation? Okay, I'm just going to print out some summary statistics because I don't feel like doing binning. So what I'm going to do is I'm going to say num with 0, num with 1, and num with more. This is a poor man super boring distribution function. You say for count in tracking, if count is equal to 0, num with 0 plus equals 1, elif count is equal to 1, num with 1 plus equals 1, sorry, and elif count is greater than, oh, I can actually just put an else in, num with more plus equals 1, and now I can print these out. I print num with 0, num with 1, num with more. And this is now a nice summary of the data. Let me just copy that into my Etherpad. And I'll save it. And if we run this, assuming it works, we can see that there's 95% of our sequences have no ends in them, 4,000 have one end in them, and 443 have more than one. And I guess if we want to actually get some vaguely interesting biology out of this, or vaguely interesting science out of this, I would say that if you print the sum of tracking, then what you can see from this is that there are 21,000 ends overall, and only 4,000 sequences have one, and 400 sequences have more than one. So what you can actually know from this is that many sequences, there's a couple sequences, there's like 450 sequences that have a lot of ends in them. Anyway, so, okay. So we good so far on this? Okay. Let me go back over to my count ends function, my count ends code, and actually now delete these load sequences. This is now the count end script that we wrote first. I'm going to get rid of those function definitions, import utils, and do this utils.load sequences and utils.countends. And now if I run, let me just make sure it works. If I run countends.py on E. coli ref 100k.q, so now you get the same answer that we've been getting all along, but our code is now split out into three scripts, right? We have countends, we have enddist, and then we have this utils.py that is in common. Okay.
Back up a second. I was confused.
Sure, yeah.
What you were doing when you were printing the tracking and
Sure. Sorry.
It was interesting biology, but I couldn't.
So sorry. The question that I was getting at is, are the ends distributed evenly across all sequences, or are there some sequences that have a whole pile of ends, whereas others have versus many that have none, right? And the answer is that a quarter of the sequences. So if you run this code again, you see that 4.3% of the sequences have exactly one end. 400 sequences have more than one end, and there are 21,000 ends total.
I got the distribution. The next number that I can't read.
The 2966. The 20. Oh, I'm sorry. That's just me being. So what I'm doing here is I'm printing the sum. I'm summing everything in the list of this is the total number of ends in all the sequences. I'm summing the individual count of ends in each sequence across the entire
That
list.
should be the total number of ends.
That's the total number of ends.
Yeah. Okay.
2966. Okay. Good so far? Okay. What's the sort of what's the sort of comfort level? I mean, there's some. It's not a huge amount of code, but there's some new concepts people are okay with. People are pretty good with where we are. Okay. Okay. So good so far. Let's do something. Let's do something else. So let me just make sure I have all these things written down that I want to cover. So just to go over, modules provide namespaces for functions and variables. Okay, so I didn't tell you about variables, but if you put a variable in the module, like I don't really have a good reason to put a variable in the module right now, but you know, if in the utils.py module I had here, I know what I can do. This is a little contrived, but it's always good practice to put in a version of your functionality. So now in my ndist.py code, I can say print using version utils.__version of utils.py. Right. And so the variable, sorry I named it. Let me not name it __version. That's traditionally how you're supposed to name such things, but it's probably more confusing than not. Right, so I have a variable called version, and if I import utils, utils.version is just the value of the variable version in the module utils.py. Right? Yeah. And let me just make sure I saved all of those. If I run that, you'll see using version 0.1 of utils.py on the output. So you can put variables in. Okay, so here's the problem with this. You should treat those as, so those are, gosh, I really should have put together a diagram for this. So, so those variables are program-wide. When you're running Python and you import utils.py, utils.version is shared everywhere in the code that uses utils.version. So if you have one module that accesses utils.version, another module that changes utils.version, then the module that changes it will change the value of it for everybody using it at the moment. Not once you exit Python, but only while you're running. Within one execution of Python, you can change the value of version, and everybody will see that changed value. So it's what's called a module global. It's global within the namespace of the module. The short, that was probably not super obvious. Don't ever change this value anywhere except here, because it will be changed for everybody that sees it. You might be tempted to do something like have count ends and load sequences, set variables within set module global variables. And the problem then is that as soon as you want to load sequences from two different files, whichever file is loaded later will override the module global variable.
Quick question. Do functions have to do global version to do change access to the module globals?
So okay, so suppose total num seeks. Let's do something. There's no real reason to do this, but you know, let's keep track of the total number of sequences this count. So here what we're doing is we're keeping module level track of the total number of sequences we've ever loaded with load sequences. And so this will persist if we load several different files. This will sum across all the files we're loading. And so what Travis was asking is, can you do this? So actually, I should really know the answer cold, and I believe you can do it. But I've now forgotten. There's something going. This gets complicated. Wow, this is an example of my. I knew this a second before you asked me. I knew the answer to this. It is generally good practice, I will tell you, to do something like this. If you're going to use global variables, this will ensure that whatever you're doing down here is accessing the thing. I think this is what doesn't work. So just close your eyes, everybody. I think if you do total num_seq equals 5, different versions of Python or different behaviors, and I now forget which, this will cause problems. Because what you're doing here is you're declaring a new variable. You could be either trying to set the global value or declaring a new variable. And Python would, I would be confused reading this code as to why you were doing this. Down below, you're incrementing a variable that already exists. So Python will know to go to the global namespace for that. So this is good practice and makes things explicit as to what you're doing. All right, I'm actually going to get rid of this code because it's really not a good idea. So I've been using this term namespace.
Yeah, I get a global variable when I try to increment.
When you try to increment, you get, okay, so you need to do the global. Yeah. I know that various bits in behavior have changed between Python 2.5, 2.7, and 3x around how module scoping goes.
So without global,
okay, so I've been using this term namespace, and all that namespace is this is going to be really silly, is a space for names. So the real point about namespace is that you can group together functions and variables under a common prefix, and that's what we're doing with utils.py. Okay, so modules provide namespaces for functions and variables. They're and probably the primary element of code reuse. I tend to organize my code like you've seen here. I have scripts and I have modules. The modules contain the code that's shared between scripts, and then the scripts do something with that code. Okay, I haven't shown you. Let me do one last one. I'll do 2 more things, and then we'll take a coffee break. So the first is that you'll notice in this code, so this is this ndist.py code. I didn't put things in a main function. Let's do that first. There's a reason for doing this. It will not be immediately obvious. We'll get to in a little bit. Okay. This is now all in the main function, and then I'm going to run main at the bottom. Let me just verify that works, and I'll copy and paste the whole thing. I just tabbed everything in. Get the same numbers. Let me put this over in the Etherpad. And you can see it. Okay. So we're here. We have this main function. There's some additional sort of boilerplate. I'm not sure what the right term is. Boilerplate is probably the right word. I'm going to put this if __ name is equal to __ main here. And what this lets us do is import this file in Python as well without executing. So I'll show you an example of how this all works later on when we're writing some tests. But what this says is, if this code is being run as a script, run the main function. If it's not being run as a script, don't run the main function. Now, so far we've only run it as a script, so you have no reason to believe that we should do anything else with this. But if we include tests in this file, the test runner will want to be able to load the file without running the main function. I'll show that to you after the coffee break. So this is extremely common. It's that last bit with this. And this prevents execution of the main function except when this script is being run on the command line. Just to show you exactly what that does, let me save this. Okay, the problem is I can't actually import the script because I named it with a dash in it. But I'll show you. Let me show you in a new script. You don't need to do this. But if I do foo.py and I say if name equals main, print executing as a script, and I can say print executing on import, executing in a function. Okay. So I think this will all work. So this is a file foo.py. If I import this function, if I import foo, it will execute executing on import. It will print executing on import. If I run foo.f as a function, it will print executing in a function. And if I run Python space foo.py at the command line, it will say executing as a script. So let me demonstrate that by actually executing it. So if I do Python 3 foo.py, it'll say executing on import, because in order to do anything with the code, it has to import the code. And it will also execute this last block, executing as script. If I do Python 3 import foo, it'll tell me executing on import. And if I do foo.f, it will now say executing as a function. But I can't actually get that executing as a script from within Python easily. I have to run it as a script. You can actually by doing this, but is it exec? Running. Okay, never mind. I don't know how to do it. Okay, so is sort of the different behavior of these code blocks? Is that clear what's going on? If not, why? These are Python conventions, or Python conventions is the wrong word. This is Python specific, although most languages have ways to import code versus executing code. Okay. So if name equals main is only run on execution, not import. I tend to use main as the main function and execute it in the main block. I'll talk about packages afterwards for people that are interested. Let's do a little bit of argument parsing first. So one thing that you may have noticed let's take a look at this ndist. How do you know what to run, right? Suppose somebody hands you ndist.py. You're like, okay, here's a script. You're like, okay. You try running it, and it says index error, list index out of range. It's like the least helpful error message available, especially if you're not a Python programmer. If you're a Python programmer, you can probably look at the script file and like figure something out. If you're experienced at Unix, you can go, oh, sys.argv looks vaguely like something else I've heard of somewhere else at some point in time. So probably it's looking for some argument, and then you have to figure out what the argument is. All very annoying. Let's instead use the argparse module. What argparse will do is it'll let you set up arguments and help text associated with them. So to use argparse, do import argparse. And the boilerplate at the top is parser equals argparse.argument parser. Args is equal to parser.parse args. And we'll add one argument here, which is parser.add argument sequence file. And we'll just leave it at that for the moment. Okay? Okay, so what that does is it creates an argument parser. It adds it tells the script, the argument parser, that you should be expecting one required parameter. And that required parameter is sequence file. And then it's saying, okay, now go ahead and parse whatever was given to this script in that context. And now we can do this very nice thing here where we replace sys.argv square bracket 1 with args.sequence file. Where it's getting sequence file from, where it's getting this from is from this. Okay, so I will copy and paste all of this into the pad. Let's try running it. Now if you run Python ndist, look at that. Okay, it's not the prettiest thing on the planet, but look at that. It says, here's how you run ndist.py. It's expecting sequence file. Immediately you should know that, right, if you're assuming you're a genomics or bioinformatics, you'll know that what a sequence file is. You may not know that it's a FASTQ file, that will come later. And then it's saying too few arguments, and it's actually telling you that there's a help. It actually automatically provides a help message. It says, when you specify -h, it tells you there's a positional argument called sequence file, and that you should provide that. You can actually do something even nicer, which you can say, you can provide help text. You can say, help equals a FASTQ file full of sequences. And now, that was just provided a help string. And now, if you run this, when you run -h, it actually gives you some really useful output, which is something useful for the user. Now, if you're anything like me, you write a lot of scripts, and you forget instantly what's supposed to be passed into them. And so my boilerplate script now is, I have a main function, it imports argparse, it does this, and then whenever I run the script, I sort of can go back and remember what it takes. Okay, but you can also do a lot more. And I'll just show you one example here, which is, suppose we wanted an option. So we wanted to say, I don't know, what's a good option here? I'll put in a version flag, and I'll say --version and help equals print versions. And then down here, I'll say if args.version, it'll print out the version string. I can copy all of that. Now with optional arguments. Okay. So we're defining a set of argument. We're defining an argument parser. We're adding an optional argument -v. The dash, that's always what the dash and the double dash mean. It print versions, and then we're saying if that flag was passed in, print out what version of utils.py we're. So let's try running that. And now when you do -h, you'll see it gives you useful help text. And if you run -v, it still wants a sequence file. And if you specify E. coli ref 100k.fq, it'll say too few arguments. Okay, what's going on here? Oh, it's expecting by default. It's expecting. Sorry, my bad. It's actually expecting an argument here. So you need to do this action store true. And what that does is it tells argparse that this is a Boolean flag, and then when it receives the -v, it should set args.version to true. Okay, now when I run this, it'll say using version whatever of utils.py, and then it'll print out the rest of the stuff. So typically, what's really nice about this is that this argument parser will do everything the way it's supposed to once you have it configured right. It'll give you a help message. It'll give you optional flags, and you can add flags as the behavior of your script changes. So, for example, what's an example? So I can't come up with a simple example, but you could say, well, I want this file to sometimes generate a plot. I don't always want it to generate a plot, but sometimes I want it to generate a plot. And then rather than putting in like hacky if statements throughout the code that you comment or uncomment or whatever, you can actually say, you can actually add an argument, print plot, -p. And when you give it the -p, it'll print the plot, it'll give you a plot, and when you don't, it won't. And it lets you sort of add this configurability to your scripts. So a lot of the time, you're not writing scripts for anybody else to use, right? You're writing scripts for yourself to use. And this just gives you an element of configurability over your scripts that comes in really handy. So, yeah. So just to finish up, what I'm just going to say is, oh, and then I'm going to do one last thing. At the very top of every file, you should have something like this. And what this does is it says, this is a script that should be run using Python 3, and it's going to use whatever version of Python 3 is in your path class. That's what the user bin env does. If you put like user local bin Python 3 or user bin Python 3, that hard codes what Python 3 it's going to look for. So it may run on your computer, but it won't run on, it may run on your laptop computer, but it won't run on your cluster. Here it says whatever version of Python 3 is first in my path, use that. And that'll come in handy when we're doing virtual envs, which we'll do right after the coffee break. It presents as a comment, so if you, let me just put this in. It presents as a comment, so if you run Python, you can still run an old version of Python. Here I'm running Python 2. You can still run Python 2 on the file, but if I try to run it as a script, it'll tell me it's not a script. I can change it to be executable, and when I run it without an explicit Python version, it'll run the right version. It'll run Python 3. I sort of went through that pretty quickly, but basically, oh, that didn't work. Chmod plus x script name. This at the top of a file made executable with that means that you can specify the version of Python to run a script with. This is actually a generic Unixism, so if you're running Perl, if you're running Ruby, if you're running Bash, a Bash script, the pound, it's called a shebang, the pound exclamation point, tells Unix, this is a script, here's how you run this script. It has to be at the very top of a file, it has to be at the very top of a file, and it will turn it into a script. All right, so let's take a 10-minute bio break and coffee break, and then we'll come back at 10:55. Sound good? Yeah, question?
Can you post the most recent utils
Which one? You post the most recent util. Sorry, yes. Most recent utils.py is. I will also actually put it on GitHub momentarily. Let me just go ahead and do that.
So you just start. But it should, and I should to all will be there too, but it's the tricky bit is getting, because you're using so many modules. Like, getting those standards of modules installed. Both names, I forget, like, how it's also means the three, but not the two.
Oh, can you not
And sometimes it's not easy to get working on that.
Yeah.
Yeah, I was, in fact, I have my editor set up so that like a key combination,
So
it runs the program that I'm edit. So I don't have to switch terminals and run that file, I just do it. Ooh, kind of regression. Yeah, so like,
Ooh. All right. Okay. So, so we've taken some code, we put it in a module where it's reusable. I think that part was pretty easy and straightforward to understand. And now we face the second problem that comes with code reuse, which is what happens if the code you're reusing is wrong. And here I can bring some personal experience to bear, and I'll just say that as far as I know, every single time I've reused code, even fairly simple code, I found bugs in it. So basically, I have two types of projects. I have projects where I'm like doing some data analysis for a paper, and I do the data analysis and I put the results in the paper, and then I publish the paper, hopefully eventually, and then I'd never reuse that code. And I have other projects where I write the code for a paper, or utility for a paper, and then I reuse that in a later paper and I find a bug in it. May not have affected the results of the first paper, but I find a bug in it. So there's sort of two lessons you could take from this. One would be that that only code that I use more than once has bugs in it. I think that would be an unlikely and statistically indefensible statement in my personal experience, and also the experience of the industry. Or it would be that there's always bugs in code. And that tends to be my actual experience. We actually have a project where we've invested fairly heavily in software engineering approaches called KCHMR. We've been developing it for almost a decade now. And despite having very high test coverage, testing the bejesus out of it, having many different people work on the core functionality and doing code review, every 3 to 9 months we find another bug buried in code that's used fairly widely in that package. So it's just one of these facts, like code's always wrong, sometimes it's useful. So what I want to show you is some beginning strategies for making sure that the code that you're reusing works. Yes?
There's a quick question.
Yeah, okay, cool. Etherpad here. Okay. So what tells argparse the difference between an optional and a positional argument? Is it just the presence of a dash? So there's a couple different. Okay, so let's go back to the code. There's a couple different. I'm sure there's a best answer that I don't know, but I will say that there are two different things you can do. You can say, I think the default answer is if you don't have a dash in front of it, it's not an optional argument. If you have a dash in front of it, it's an optional argument. Makes sense. So what you see here is the dash of e dash version is optional, and the sequence file is not because of it doesn't have the dash. You can, however, do something like this, and this will actually break the code if you do it. But what you're saying is the number of arguments is either 0 or 1. By default, nargs for arguments without a dash is going to be 1. That is, it expects sequence file and it expects one thing in the place of sequence file. If you specify nargs equals question mark and you run this, you should be able to run it without, right, you should be able to run it without it complaining that you're not giving it an argument, but now the argument args.sequence file will be none because you didn't give it anything. So you can override so the default is to require it if it doesn't have a dash there, but you can override that with this nargs. You can also do this other fun thing, which is you can specify things like plus for nargs, which says 1 or more, and that's how you give it a list of files. So if you want to be able to give it 5 different sequence files, you can say plus. The thing that happens then is that args.sequence file becomes a list rather than a file name, rather than a string. It gives a list of strings rather than a single one. Yes?
So if we add this now and run it, it'll work just fine because the list is of one.
No, but I'll show you. What it will do is args is that load sequences will complain because you're passing it a list rather than a string. So if we run it with plus, It'll say, okay, the following arguments are required because I didn't run it with anything. I'll run it that, and now it'll say, now args.sequence file will complain because it's trying to open a list rather than a single file. So what you need to do is change ndist.py to do something like this for file name in args.sequence file, seeks plus equal. Right, you need to basically do a for loop to load all your sequences in. Does that make any sense? And that should work. Let me try it. Okay, I can run it with one and it works. And then can I run it with multiple ones? I can run it with multiple ones and it just loads the same sequence file in twice. Does that make? Do you see what the code's?
So it doesn't, it won't give you two sets of outputs, and
No.
it just mash them together.
Right. Yeah. Well, that's because that's what we've told it to do here. Yeah. Yeah.
Everybody familiar with the Python documentation online?
So that's a good
They
point.
answer
So
all of this stuff in great depth.
so if you do docs python argparse, you'll find complete documentation for this.
And at the top, the Python 2.7.11.
So I can make this Python 3.5,
The version you're using.
and you'll see there's a tutorial, there's examples, there's all this other stuff there. Yeah. So I'm not going to comprehensively cover argparse.
No.
But
For every built-in module that exists.
yeah. So I'll copy and paste this latest version of ndist into the. I'll put it above the all bugs have code how to test. Okay. So where were we? Here. So once you have code that you use in multiple, okay, so back to testing. Sorry, unless there are any other questions on argparse. Okay. Okay, so once you have code that you use in multiple places, now you want to think about how to make sure it works. There's a couple different ways to do this. The place that I would suggest starting with is actually not what I'm about to show you. What I would suggest starting with is have a shell script. And let's name it test.sh. And this shell script can contain commands that should work. What was the command I was running? Right. So this is a command that should run, right? And I'm going to save this as test.sh. And then if I just run bash test.sh, I got that command wrong. It should be ndist.py. If I run this, it'll run the command. And the goal of this is not to verify any outputs or anything, or verify that it's working. It's just to verify there aren't any syntax errors or stupidities in your code, right? You make it really easy to run your code on something quick, and that way, whenever you change it, you can be like, oh, does it break? If it doesn't break, you can't conclude that the output's right, but you can conclude that at least you don't have syntax errors in your code. And there's going to be a couple statements in here that I make where people are going to look at me like I'm an idiot. Like, of course, I'm not going to run the thing with syntax errors in my code. It's easy to say when we have 3 files and we're changing them one at a time. But when you have 5 different files and some of them are modules and some of them are scripts, just being able to make sure you can run all of the scripts once is actually a remarkable time saver. So, having a command that runs a bunch of scripts on some obvious input that should work is actually a really good sort of thing to do. But we're not going to focus on that. We're going to focus on writing tests for your actual code. So let's look at this utils.py code first of all. What I like to do is I like to start by my testing by I like to start writing automated tests that do something incredibly obvious. So in utils.py, let's add a test, and we're going to call it test count ends, and I'm just going to name it test count ends. Doesn't matter. It's going to be a function that takes no arguments. And what I'm going to do is I'm going to manufacture a sequence. So let's name the sequence. Let's just name the sequence seq, and I'll put in 1n and HEGC. Okay. And now I'm going to call count ends on it. Okay. So what should NB be after running count ends here? Good catch. 5. Yes. Okay. What should NN be? 1. Okay. If NB is 5, if NB isn't 5, what can we conclude about our function count ends? Doesn't effing work. Right? Can we conclude that if NB is 5, can we conclude that count ends works? I mean, no, right? All we can conclude is that in one case it gives the right answer, right? So this is where I actually think teaching testing to scientists is easier than teaching testing to like software engineers, because we're all used to the idea that like just because we get the right answer in one situation doesn't mean that our data is good, right? It just means that we have to look deeper to find the bug or to find the problem. Okay, so we have this test function. And we know what NB and NN should be. What we want to do is make Python complain loudly when that's not true. So I'm going to introduce this statement assert. And assert is actually a Python built-in. And what assert says is if the condition is true, do nothing. So here we're going to say NB is equal to 5 and assert NN is equal to 1. And all that's doing is it's saying, you know, we can actually we could put parentheses around if we wanted to, but it's saying complain if NB is not equal to 5, complain if NN is not equal to 1. And then the last thing we need to do is we need to run this test function. Okay. So I'll just say this is at the bottom of utils.py. Let me just put this. Put this at the bottom of utils.py. Okay, everybody sort of good with what this code, well, let me run it. So now I'm going to run utils.py, and it's going to do nothing. How do I know that it's working? Well, let's break something. Let's change NB to 4, save that, and run that. So now I've intentionally broken my test, right? I've changed NB, I've changed the test, I've changed my assert statement so that NB is checked for the wrong value. And what you can see here is you get what's called an assertion error. And the assertion error, you can actually put a nice message in. You can say NB should be 5. And when you run it, now you'll see this error. And this error basically says, hey, you ran this assert statement. The assert statement, we wanted to assert that NB was going to be equal to 4 after whatever we ran above, and it's not. It actually is. It's actually something else. So we can change this back to be NB equals 5. Oops, and have it pass. Okay. So are people, okay, so this is sort of, I feel like sometimes people think this is unnatural. We're writing code to run other code and verify that the values that come out of that other code are correct, right? So it's sort of this recursive problem where you're writing code to test other code. And the only thing to keep in mind is that, so it turns out, once you've been doing it for a while, it turns out to be very natural. The only thing to keep in mind is that your test code, the code that is testing your other code, should be very simple, right? Here, we're not doing anything complicated, which means we don't really have to worry about whether our test code is correct as much. We just have to worry about whether the code we're testing is correct. Okay. So there is one more problem. Does anybody note that, so with our module stuff that we did before, this test count ends function at the bottom is going to be run every time we import this module. Right? That's not something we want. Do people, right, so let me just put in a print statement so you can see. So print running test count ends. So we save this, and now when we run it, you'll see it's running test count ends. And if we also run ndis.py, it's actually running test count ends as well. If we have a lot of tests, we don't want those tests to run every time we import the module. Right? Especially not if some of the tests might break, because then that gets very confusing. I mean, it's like you might want your code to break if any of the tests are breaking, but you might not want. It sort of depends, because some of the tests might be for different platforms, right? There might be tests for Windows, and if you're running on Linux, you don't want to run those tests. So that's where this block thing comes in handy. Because you can do if name equals main here. And now, whenever you import this file, it won't run the tests. But when you execute the file as a script, it will run the tests. So I'll post all of this in a second as soon as I run it. So now if I run ndist, it's using utils, but because it's importing utils, it's not running that code. If instead I do python utils.py, it's running the test. So essentially, we have tests that run only when we actually want them to, when we're running it as a script, versus when we're importing it. Does this make some sense as why you might want to switch between the two? Are there any questions at this point? There's a lot of impassive faces out there and a lot of people going, sure, I understand this. Okay, we'll tell you what. Let's write a few more tests just to have this sink in a little bit more. What horrible things can go wrong in count ends? I mean, it's only 3 lines of code, right? How badly can we treat it? Okay, can somebody give me a sequence that's going to break count ends? Okay, so this is you're running into the mental blocks that come with writing tests. Is my prediction. And the mental blocks are, well, the sequence does the function does exactly what I told the function to do. Why wouldn't it work? Why would it not work for something? Well, so this is the interface between your domain expertise, let's pretend you're a bioinformatician or a genomics person, and your coding. Yes, the code is doing exactly what you wrote the code to do, but from a genomics and bioinformatics perspective, there's a lot more that it could be doing, right? So let's say that we don't know that the sequences that we're getting are uppercase. Suppose that they could be lowercase. Right? Okay, well, what happens if we write another test and we pass it some lowercase data? We pass it some bad data. So we're going to make a new function, test count ends 2, and we're going to pass it a sequence with lowercase n. Is that going to work? Well, the code will work as we wrote it. It's going to return, but it's going to return 0 ends. It's not going to return 1 end. People? Okay, so two questions for you to flag me down with. One is, do people understand the basic test code there? Right, we're creating a fake bit of data. We could create a fake bit of data and put it in a file, right? We could be doing these things by putting them in a file and then running ndis.py and making sure that the answer is correct. Here, but here we're actually testing the function rather than the whole file, rather than the whole loading the sequences and so on and so forth. So we're manufacturing bad data. We're running a function count ends on it, and we know what the answer should be because we manufactured the fake data. Okay. And the problem that we're running into, the thing that we manufactured, is that we actually want to be able to count both uppercase and lowercase ends, not just uppercase ends. But we manufactured some data that had some lowercase ends in it. So let's try running this. And what you'll see is, of course, that it doesn't properly count. It doesn't properly count lowercase n's. So let's fix the code. So how would we fix this code? How do we fix the count n code to properly count lowercase and uppercase n's? Any suggestions?
Make them all uppercase.
Make them all uppercase. That's one approach. Any other? There's another approach. So count, the count function here won't ignore case. I don't think there's a way to make it ignore case. You have to either uppercase the whole sequence, which is what people are suggesting, or
You go twice and a half.
or you count lowercase n's, right? So you could do this two ways. You could say lowercase n, or you could say seek.upper.count. Is that going to work? That should work. And if we run that, our tests now pass because we fixed the sequence. Copy and paste this all. Okay. So let's see. Are there any other ways that this count ends function could break? Well, if you're a genomics person, you could say, how do we know that the sequence is actually how do we know that this is actually a valid sequence? Any? So suppose somebody passed us a FASTQ file of protein sequences. Let's assume that you don't really get FASTQ files of protein sequence. Well, let's assume someone's handing us protein sequence. And really, we only want to use count. And in protein sequence, usually X's would be, right? N is actually a valid amino acid code. So you don't want to count N's. You would want to count X's anyway. So how would we write this function to exclude protein sequences from being passed in? What sort of condition would we want to write on count N's?
It has to be dot upper equal
Right.
dot upper in.
Only valid input should be strings of A, C, G, T, and N, right? That's the only thing that should be there. Now, there's clever, fast ways of doing this, and I'm not going to use any of them because the code gets complicated. So what I'm going to do is I'm going to do this. I'm going to convert seek into uppercase, and then I'm going to say good bases is equal to seek.count A plus seek.count C plus seek.count G plus seek.count